Welcome to module 4 that is called data visualization with Matplotlib and Seaborn. What is Matplotlib and what is Seaborn? We'll talk about it later on. First of all, let's focus on what is data visualization. And even before that, let's see what we are going to achieve in this module. So first of all, we will talk about what and why. So what is data visualization and why we should learn data visualization. And then we'll talk about Matplotlib. Inside Matplotlib, we'll be talking about line chart, pie chart, how we can represent multiple charts on one screen, how and a little bit of image processing as well. And here we'll be building up an application in which we will try to look at the method how we can crop an image, right? And then we'll talk about Seaborn, that is also a state-of-the-art data visualization library of Python, in which we'll talk about dist plot, relational plot, cat plot, joint plot, and correlation heat map. What are these plots and what are these maps? We will talk about it. Before that, let's talk about what and why we should learn data visualization. Data is usually in statistical format. Why we should visualize this data on a chart, on a plot, on a map, or something like that. So here are some insights from different papers that says visuals are processed 60,000 times faster than text. That is a huge number. And brain retains visual information better. Obviously, if we have let's say a million integers or 1 million numbers in a sheet, it is almost impossible to memorize those numbers. But if we can visualize those numbers in a format of maybe a chart or a line graph or a bar chart or something like that, it will be very easy for us to remember that chart. Moreover, by 2025, it is estimated that there will be 163 zettabytes of data all around the globe. Now, this much data will be almost impossible to contain, although there will be mechanisms to contain the data. But what if we throw away the data but we keep the insights from the data? For example, if we have 1 million numbers but we just draw one graph chart of those numbers that provides us the insights of that data. So it will help us in summarizing the data as well. Moreover, companies that use data visualization are 28% more likely to find timely information for decision making. That is available in white paper that is produced by IDC. 70% of business leaders believe that data storytelling is a critical skill for organization. Presenting figures, if you have a lot of figures, it will be very difficult for us to present it in a meeting or anywhere. But if we can translate those figures into a storytelling thing or data visualization thing, it will be very easier for us to convey the message, convey the insights of the data. And it will also save a lot of time as well. Social media posts with images or visual content get 94% more total views and engagements. That is huge. So we are determined that data visualization is an important tool to have in hand. So let's get started with data visualization. So Matplotlib is basically, you can say, a basic and pioneer library in Python that helps us in visualizing the data. A lot of, you can say, advanced libraries of Python that are available in market that help us in data visualization. They are mostly built up on the top of Matplotlib. For example, even Seaborn, that we will learn later on, that is built on the top of Matplotlib. So Matplotlib is probably not a very fancy library, but it is you can say a very powerful library. So let's learn about the basics of Matplotlib. By using Matplotlib, we will try to create line charts. We'll try to create pie charts, multiple charts, and we'll also perform some image processing in which we'll see how we can crop an image. Right? We can crop an image in our mobile phone. So how we can write a code to crop the image. Cool. So let's get started. And here, first thing first. How we can install this library if you don't have it beforehand. So again, the same process. We'll say pip install what? Install Matplotlib, and that's it. You'll have to run this cell. You'll hit run button, and it will work for you. I'm gonna comment it because I already have it. So I'll say import Matplotlib dot, so I don't want to work with the whole Matplotlib. There is a module inside Matplotlib that is called pyplot, right? So I'll say import matplotlib.pyplot as plt, right? Again, this is an alias. You can use any name over here, but overall the convention is plt. We usually use plt over here. So one more thing, we'll import numpy as np as well, because we'll work with both of these libraries. Okay, so here let me create a numpy array. So I'll say numpy.array. I hope you guys are familiar how to create a numpy array, right? So let's say I have an array that says 0, 3, and let's say 6, and then I have another array that is called y, and here I have values like 0, let's say 50, and let's make it 250, right? So I just chose 3 values in each array randomly, and if I display the arrays, it looks like x array looks like this, y array looks like this. Cool. Now plt, that is the alias of matplotlib.pyplot, plt dot, I'll say plot these 2 arrays. So I'll say x and y. That's it. Here we go. So we had 3 points in each array. So first point, whenever I say point, it means it has 2 coordinates, x coordinate and y coordinate. So first point was 0 and 0. X coordinate and y coordinate both were 0. So this is the first point over here. Cool. And then the second point says 3 and 50. So on x-axis it is 3, on y-axis it is 50. So here you can see that 3 for x-axis and 50 for y-axis. And third point is 6 and 250. And here we go. This is how it is denoted over here. Cool. Okay, so what if I want to I will update this graph, and I'll make it like let's say, let's add another number over here, 0, 3, 6, and then let's say add 9, and here let's add 200, right? Now it should increase at x-axis, but it should decrease on y-axis, right? So run it. Here we go. So up till here the graph is exactly same, but after that the last point says 9 on x-axis, 200 on y-axis. So that makes it this point, right? So we have overall 4 points, 1, 2, 3, and 4, right? So 4 points are joined by a line that is called plot in Matplotlib. So this is, here you can also see it as a 2D line, simple 2D line that is joining all the points that are available over here. And make sure the number of points, the number of coordinates in both of the arrays have to be equal. It is, I mean, it will be an error if you will write 3 coordinates over here and 4 coordinates over here. So the number of coordinates in both of the arrays have to be equal. Now go ahead and practice it. Experiment it at your end, and in next video I'll show you how you can create data visualization on, let's say, on the topic of some sports or something like that. So I hope everyone is familiar with cricket. That is a sport. So we are going to visualize the score of a cricket match, and we'll compare the score of both of the teams in a cricket match, right? So first of all, let me introduce you with the function of numpy that is called arrange. So there is a function in numpy that is called, oh, it is with single r, yeah, arrange. So in this function, if I need to pass 3 parameters. I'll say, let's say this is first parameter, and then this is the second parameter, and then third parameter is going to be the jump, and this is the jump. So it will create an array for me that will start from this part and over here, and it will take a jump of this much, right? If I run over here, here we go, 0, 2, 4, 6, 8. It will stop before 10. So if you want to include 10, then you'll have to write 11 over here. Now you can see from 0 to 10. Okay, so we are going to make use of this function. In a cricket match, there are, in a one-day cricket match, there are usually 10 overs. So we'll say from 0 to 51, take a jump of 10, right? So here we have 0, 10, 20, 30, 50. So we have these 6 numbers over here that we have generated from numpy, and let's call it overs. Okay, so these are the overs. So we'll basically snapshot the score over here. What was the score at 0th over of each team? what was the score at 10th over for the each team, and so on and so forth, right? So here we'll say, let's say score 1, let's say this is the team 1, and we'll say numpy dot array, and here we'll just write the score. So let's say at 0th over, obviously score will be 0 because that is the beginning of the match. At at 10th over, score would be let's say 60. I'm just hypothetically imagining it, right? At 20th over, score was 100, then 30th over score was 130, 40th over score was 250, and finally at 50th over score was 310. Cool. Okay, so this was the team 1. Now let's talk about team 2. So let's store it in score 2. In the beginning it was 0 as usual, then let's make it 30, then let's make it, I don't know, maybe 70, team was lacking, and then let's make it 125, team was picking up, and then let's make it 200 and let's say 70, and finally let's make it 300, which means that score for team 2 was lesser than the score for team 1 at the end of the match, right? So here we have the data ready that we want to visualize. Now I'll say plt dot plot as we done previously. On x-axis I'll plot the overs, at y-axis I'll plot the score 1. Cool. And okay, so if I run it just like this, here we go, we can see this line where we have visualized this data only, right? But I want to visualize the second score as well in parallel so that I can see what is the difference and where is the difference, right? So here I'll say score 2. Again I'll plot another plot, and I'll make it over. I'll make overs on x-axis and score 2 on y-axis. I'll run it. Here we go. It has automatically detected and it has changed the color for score 2 into the orange color, right? Okay. Now again, it is not making a lot of sense, so we need to add some labels and stuff like that. So let's do that. Okay. So how we can add labels? So we'll say plt dot title. What should be the title of this chart? So we'll say summary, summary, summary of match. That is going to be the title. And then I'll say plt dot x label. So what should be the label on x-axis? Obviously on x-axis we have the number of overs. So I'll say number of overs. Cool. And the same goes out for the y label, and that is going to be runs, or maybe let's call it scores, right? And that's about it. So if I run it, now here we go. We have a nice title over here. We have title for x-axis, number of overs. We have a title for y-axis, that is score. But it is still a little bit difficult to track that where is 200 over here and where is 40th over here. So let's add some gridding scheme as well. So over here, if I'll say plt dot grid, okay, it will add grids over here. Here we go. Right now it is, you know, quite easy and simplified to track. Let's say I want to track the score in 20th over. I can simply go over here. So in 20th over, team let's say team 1 had the higher score, that was almost 100, and team B, or let's say team 2, had a score of let's say 75 or around 75, right? Or let's say 70. So this is how you can visualize the summary of a match. Now here you can visualize the sum, and moreover at the end you can see the team blue is winning because it has higher score over here, and team orange is losing because it has lower score. Now imagine you can visualize any kind of a data over here. You have data from retail, you have data from stock market, and or anywhere. You can simply load your data in NumPy array and you can plot that data over here. Moreover, in cricket we also want to track where was the out, right? So we want to see where any player got out. So we'll simply say plt dot plot, and here we want to do what? We want to mention that we need to mention both of the things, at which over each player got out. So we'll say 10 and 20, and one more we'll say 60 and 100, right? And one more thing, we need to mention that which marker do we want to use. So we want to use O marker over here, and here we go. So you can see here is the O marker, that is at the score at the over at 10th over, right, and 60th score. So you need to match it like this, 10th over and 60th score. So this was the x-axis and this was the y-axis. So here we have a dot, green dot over here. You can also change the colors as well. And then at 20th over and 100th score we have a green dot over here. You can also add these dots for orange line as well, just like by using the similar fashion, right? So this was, you can say, a very basic application of Matplotlib that helps us in visualizing the data. What if I want to create multiple charts over here? Let's say I want to create one chart for team blue and another chart for team orange, right? I don't want to mess up my one chart, but I want to create multiple charts. So let's simply pick up this data and come over here into the new cell and create subcells, right? So and before we create subcells, let me simply show you guys how it would look like in one cell. Here we go. We already know how it looks like in one cell, so let's do that in multiple cells. Cool. Okay, so before that, what I have to do is I have to say plt dot subplot. Okay, so in subplot we have three parameters. First of all, we need to mention that how many total number of plots do we want to create. So let's say we want to create two plots. In first plot we will plot this blue line, and second plot we will plot this orange line. So two over here. Okay, and then we need to mention that the plot that we are going to create right after this subplot should be at which number, right? So for example, here we have two plots, which means that we will have one row and two columns. So we'll say row number 1 and column number 1. There should be this plot, right? And same goes out for the second one. And here we need to change the schema, that is, we don't have to change the schema actually, we just have to change the numbering. So at row number 1, column number 2, we want to plot this chart, right? So if I run, here we go, right? Now you can see both are blues, but they are the different charts. You can also add the labels as well. You can add the X title, Y title to each chart. You can do all the things that we have done over here, right? So this is how you can create multiple charts. You can create two charts, you can create 3 charts, 4 charts, or as many charts as you want. Okay, moreover, what if here the charts are created in you can say top to down fashion. What if I will do something like this, right? So now the charts are overlapping, so which means that we need to provide the schema that should be compatible with the visualization schemes as well. One more thing, what if I want to visualize different types of charts? So for example, here I am visualizing two charts that are of the similar type. For example, they both are the line charts. What if I want to visualize a line chart and a pie chart? Well, what is a pie chart? First, let's explore that. Actually, let's do that in next video. Okay, so before we talk about how we can plot multiple types of charts simultaneously, let's see what is a pie chart. So we'll say plt.pie, and here we need to provide two things. One is obviously a list of numbers that should be visualized. So let's make it 3, 5, 8, and 2, right? And also we need to provide the relevant labels as well, right? So we should provide a list of the labels. So let's say 3 corresponds to label A, 5 corresponds to label B, 8 corresponds to label C, and 2 corresponds to label D, for example, right? And if I run it, so here we go. So it creates this kind of a pie chart for us, in which you can see team C has the biggest chunk, that is 8. So here you can see that the team C has the biggest chunk, 8, and then team B has the second biggest chunk, that is 5. So team B has the second biggest chunk, right? So if you do not have a lot of numbers to visualize, then this kind of a chart, pie chart is a good one, is a good thing to visualize. But if you have a lot of numbers to visualize, then this is not a good option, because the pies will be so small that they will not be even readable. Okay, so this is how we create a pie chart. Now let's combine pie chart with the line chart that we had created before. Okay, so how we can do that? So let's simply pick up its data from here, paste it here, and then we'll say plt dot, again a subplot. We'll create a subplot. We want to create total 2 subplots. This is first subplot of first row, right? And then we'll say plt dot plot, as usual, overs and score 1. Cool. So it will be plotted on at first, and also let's write its title as well. So we'll say plt dot title, and here we'll say summary of, let's say, match. Cool, something like that. Okay, now we want to create the second plot. So in second plot, we'll again say plt dot subplot. Yeah, total 2 plots, row number 1, column number 2, let's say, and we'll say plt dot title. What is going to be its title? Its title is going to be, let's say, pie chart. Cool. And now here we want to plot it, so I'll just simply copy and paste it over here to save some time. Yeah, and I think it's good enough to show. Oh yeah, there's a typo where, yeah, it's not plot, it's plot, plot. Okay, cool. Run it. Here we go. So this is the first plot, this is the second plot, and they look horrible. Yeah, I think we should display them side by side. So if we want to display them side by side, we'll say it should be at second row first column, and it should be at second row second column. Cool. And here we go. Now it looks better. So basically we have created now 2 rows and 2 columns, which means that we have total 4 spots for the charts, but we are visualizing only 2. So yeah, that works. So here is the summary of the match. Here is the pie chart with the labels, and you can also add X labels and Y labels to this chart as well. You can also add annotations. You can also change the positioning of the labels as well. You can write the labels inside this pie chart as well. So this is how you can work with multiple charts as well. Now if you will just go to plt dot and hit tab button, I mean, a huge list of functions will be opened up. You can work with box plot, and you can work with the bar charts and bar charts on horizontal axis, and so on and so forth. I mean, it has a lot of functions to explore. So go ahead and explore these functions by yourself. And from next video, we'll be talking about image processing. So a cool thing is coming up. We are going to work on image cropping app. Okay, so let's see how we can work with image processing. So first of all, let's go ahead and read the image. Wait a minute, what do we mean by reading the image? We usually look at the image. Well, here's the image processing thing. We are going to read the image. So here's the method called imRead that is available in PLT, that is Matplotlib PyPlot library. Okay, so here we need to write the address from where we want to read the image, right? And the methodology of reading of writing the address for reading the image is exactly same as we used to write in pandas, how we used to read the CSV file, right? So the rules are exactly same. We have to write R if we are working in Windows, and if we are working in MacBook, then we can work without R as well. Now we need to read the image. We need to go over the we need to go inside the directory. So this is the image that we want to read, right? So, and here you can also see the dimensions of the image are 225 into 225, which means that its resolution is, I mean, it reflects the resolution of this image. Moreover, statistically speaking, it says that this image has 225 rows of pixels and 225 columns of pixels. So let's read out the image. We'll go to the address bar, and here we go. We'll copy this and paste it over here simply. That's it. Moreover, you need to be very careful that the extension of the file should be written over here. It will not read the data or any file, or whether it is image file or CSV file, without its extension, right? So let's run it. Yeah, it is working. Now let's see, let's output the image, right? Wait a minute, what kind of an image it is? These are just numbers. Well, let me tell you, An image is basically a collection of numbers, and if I say dot n dim, it has 3 dimensions: row, column, and the depth, which represents the colors. When we were talking about NumPy, I told you guys all the images that we see on our mobile phone screen or computer screen or any digital image, that is nothing but just an array. It can be a 2D array or it can be a 3D array. If it is a 2D array, it is going to be a black and white image, but it is a 3D array. As you can see over here, it has 3 dimensions. Then it is going to be a colored image. Okay, and if we say img dot shape, if we look at the shape, so here we go. So it has 225 rows, 225 columns, and each cell has a depth of 3. Cool. Okay, now I want to look at the image. Well, before we look into the image, let's get rid of these 3 dimensions, right? Let's just keep 1 dimension. So I'll say image img, that is the previous variable. So I'll say img, and here I'll say keep all the rows, comma, keep all the columns, comma, and keep only 1 dimension, right? That is the 0th dimension. So I want to have a sort of a black and white image. So if I run it, and now if I want to have a look at the shape, here we go. So now I do not have any third shape over here. And also if I say img.ndim, here we go. Now it is just a 2D array. If I say img simply, here we go, right? So this is simply a 2D array now. Okay, now this array has, let's look at the maximum number that we have in this array, img.max. So the maximum number that we have is 249. And what is the minimum number? Dot minimum, that is 0. Now let me briefly explain about the image processing a little bit. Okay, the maximum number that is allowed in an 8 byte of an image is 255, right? So 255 basically represents the whitest color. Cool. And 0 represents the blackest color, and in between values they represent the relevant light or dark color. Now let me just show the image over here, and then you will be able to relate where is the dark value, where is the light value. So I'll say plt dot im show, that means image show, and here I want to show the image, right? This image that I read, and here we go, right? This is the image. Now inside the image, here you can see these are the light values, these are the light colors. The hairs of the Einstein, they are light colors, but the eyeballs are dark. Probably this side of an image is dark, so all the values that are over here would be darker, and all the values that are here would be lighter. Now let's make sure that what we are saying is correct. So let's output just this chunk of this image. But how we can do that? Well, we know how to slice an array, correct? So you can see this is just an array. So on x-axis you have 225 values, on y-axis you have 125 values. So I'll simply say img is what? It is simply an array. So how we slice an array? Simply, it is a 2D array, so we'll have to put a comma over here. Now we want to slice the hairs of Einstein, so that is starting from, let's say we are talking about the horizontal axis, right? That is starting from 0 and ending at roughly, let's make it 30, right? So we'll say from 0 to 30. Now on y-axis we need values from, let's say, from 60 to, let's make it 130, right? So I'll say from 60 colon 130, right? If I run it, so these are the values that I have, and let me simply copy this, and I'll say plt dot im show image show, and here I'll paste this same slice. Here we go. Now these are only the hairs of Einstein, and here you can see that most of the values are closer to 255. Same goes out if you will try to crop this part, that is the darker part of the image, right? You will see mostly the values will be closer to 0, right? Because 0, or the values that are closer to 0, they represent the darker color, and 255 and the values that are closer to 255, they represent the lighter color. Okay, now I hope you guys so far have understood how to crop an image, right? Cropping cropping an image is nothing but just, you know, array slicing, a numpy array slicing. That's it. Now what if I give you guys an assignment? Go ahead and crop the eyes of Einstein, that is this part of Einstein image, right? That is sort of an assignment for you. So try to do that, and if you will not be able to do that, I'll do that for you in next video. Well, if we want to slice down or crop the eyes of Einstein, we first have to look at the x-axis, right? So let me add a cell over here. So I'll say img and then comma, that is the structure that we want to have, and then on x-axis, or you can say on the row axis, we need to start from, let's say, row number 75, and we should end at row number 100, right? So let's make it 75 colon 100, that is a one slice. And on y-axis, I think we should start from 100 or a little bit before 100. Let's make it 90. We should start from 90 and we should end at roughly, I think, 170, right? So let's make it 90 colon 170, right? And let's run it. Oh, again we got the array structure. Let's name it as eyes, okay? And then here we'll say plt dot imshow, and here we'll show the eyes. Here we go. So we are able to crop the eyes. Probably we can trim the eyes from right hand side a little bit. So if we'll make it 70, it will be more clear, or let's make it 80. Yeah, so from here we need to trim it down from right hand side. So from rather than 170, let's make it 160. Run it. Yeah, this is more clear now. So now we have the array in the variable eyes. Let's add another cell. What if I want to save this cropped image, right? We can save the cropped image, correct? Okay, so how we can save it? Simply we'll say plt dot imsave, that is image save. Now first of all we need to write the name of the image. Let's say eyes dot jpg. Cool. And then we need to provide the array in which the image is existing, that is eyes, right? So we'll say eyes, right? Okay, that's about it. No, moreover, here it will simply go ahead and store this image, save this image inside the directory where this current coding file is residing. But I want to save this image in my, let's say, desired folder, or let's say my data folder. So I'll simply copy the address of my data folder. I'll write R over here, and that's it, right? So this is my address of the folder followed by the name of the file that I want to name it, right? So if I run it and I'll go over here, yeah, here we go. You can see this file is created, that is being opened. Here we go, right? Since it has very low resolution, that is why it is looking so small over here. So you can crop any image according to your need anywhere you want. Moreover, just a food for thought, have you ever imagined when you edit your image and you can say add more brightness or add more contrast or do something like that, what actually happens? Only the values inside the arrays, they got changed. So for example, if you want to add more brightness, what do you have to do? You have to add more whiteness, right? So how do you add more whiteness? You will increase the values of all the values inside the array, because the white values are closer to 255. So let's say if you will add 5 into all the values, your picture will be comparatively brighter. And moreover, what if you just want to brighten the eyes? That does not make any sense, but let's just say we want to do that, right? So what you have to do now, you have to combine both of the things. You have to slice the array and then add the values inside that slice and then adjust that slice in the previous array, and that's it. Cool. So you can work with image processing as well by using Matplotlib, which is a very useful library. And from next lecture we'll be talking about Seaborn. Let's go ahead and work with other types of charts as well that are provided by Seaborn, and we are going to work with which dataset? Let's choose this flights dataset, right? So first thing first, we are going to load this dataset. So we are going to say flights underscore data frame equals to what? Equals to Seaborn dot load dataset, and here we'll say flights. Cool. And flights data frame should be output put as well. So here we go. So we have 3 columns: year column, month column, and number of passengers. So for example, if we want to see in year 1960, the month of August, how many passengers were there? So there were total 606 passengers, right? So we have overall 144 rows. And by the way, you can work with other data sets as well. Okay, so we have explored dist plot, and let's work with again dist plot as well. So we'll say seaborn dot dist plot, and in dist plot we'll say flights data frame. So let's say we want to visualize this number of passengers, right? So I'll copy this and paste it over here, and that's it. Let's run it. So here we go. So most of the result that we have is it actually starts with over 100 passengers. Most maximum passengers that we have are 600, but mostly are around from 100 to 400 or something like that, right? So this is how you can create a dist plot of any column that you have. Now let's work with other plots as well, and let's work with relational plot. Okay, so we'll say seaborn dot rel plot, and then we need to provide, since it is a 3D plot, it helps us in visualizing 3-dimensional data. So we'll say on x-axis we want to provide passengers, right? On y-axis we want to provide month, and on z-axis there's no z-axis, it's called hue, right? So that helps in coloring the data. So in hue we'll have year. Cool. And we also want to mention that the data that we are using is flights data frame. That's it. We'll run it. So here we go. That is a nice data visualization. So basically these lighter color are representing the earlier years, and darker colors are representing the later years. For example, the lightest color is representing 1950s, and the darkest color is representing 1960. Moreover, we have months over here, and in every month we have roughly 10 values. So 1 2 3 4 5 6 7 8 9, I don't know, a lot of values. And moreover, you can also see, let's say I want to have a look for a value for 1960 or around 60 and month of November. So I can simply go into the month of November and the later years. So the values are near 400, or maybe 350 and 400, something like that, right? So this is how you can create a relational plot of any data set that you have. Moreover, let's go ahead and create the cat plot. And before we create the cat plot, let's load another data set so that you guys get comfortable with working with multiple data sets, right? So we'll say the data set that we're going to use is tips, and we'll say seaborn dot load data set, and we'll say tips, right? And here we'll say tips data frame. So here we go. So we have this data set that says the total bill was this much, the tip that was given, it was this much, the sex of the customer was this, whether the customer was smoker or not, what was the day, Sunday, Monday, Tuesday, whatever, what was the time, it was dinner, lunch, or whatever, and how many people were there in that dinner, right? So this is the sort of hotel related, or you can say restaurant related data set that we have. So if I say seaborn dot cat plot, and here I say x equals to, on x-axis I want to display the days, and on y-axis I want to display the tip, right? So I want to basically visualize, is there any relationship between the day and the tip, and the data that I want to use is tips data frame, right? So if I run it, here we go. So basically we have Thursday, Friday, Saturday, and Sunday data for these 4 days. Probably on Monday, Tuesday, and Wednesday restaurant is off, and you can see on Saturday the waiters are getting more tips, even the higher tips, and on Sunday the waiters are getting more number of tips, right? So yeah, there is some and on Friday there are not a lot of customers, probably that is why they're not getting a lot of tips. Moreover, what if we want to visualize the data with respect to total bill, right? So in place of tips, let me go over here. I'll say total underscore bill. I run it. So here we go, right? So again, that is almost the same relationship. On Saturday, Sunday there are a lot of customers. On Friday there are lesser customers. On Thursday there are comparatively higher customers than Friday, right? And yeah, that's you can also work with size variable as well, and you can work with the other variables as well. So this is how you can work with cat plot. And finally, at last, let's work with the joint plot. I mean, there are a lot of plots available in Seaborn. You can explore these plots at your own. I just wanted to give you guys a starter. So here it is. So by if we want to work with the cat plot, on x-axis we'll say here is a day. On y-axis we'll say, let's say we want to work with the total bill, right? Total underscore bill. And what kind of a plot do we want to? There are different kinds of plots, right? So we want to work with violin. Okay, and again the last thing is data equals to tips data frame. That's it. So here we go. So this you can say the width of violin at each point denotes that there are more number of values, there are more density of values over here, right? So this is the violin kind of cat plot. There are different other kinds as well. All you have to do is you have to do what? You have to go to help and you'll say seaborn.catplot, and here you can find the other types as well. So kind can be box, kind can be violin, kind can be boxen, and these are the things that I'm gonna leave up to you guys, right? So you can work with different kind of plots as well, right? And whenever you're stuck anywhere, you want to explore more about any function, simply go ahead and go to this help method, write down the name of the method, and that's it. You'll find a lot of cool things to work around, right? So these are different plots that we have worked with by using Seaborn. And in next lecture we are going to in next video we are going to talk about the heat map. We are going to talk about two things. One is correlation and second is heat map. So how we can visualize the correlation on a heat map, we'll see. Let's talk about heat maps and correlations. First, let's start with correlations, right? So let's get started with tips dataset that we have. And so since this is a data frame that is available in pandas, and pandas has a built-in method called CORR, correlation, right? So if I run it, so it displays this kind of a matrix for us. So all the numerical columns will be displayed on the rows, and then all the same numerical columns will be displayed on the columns as well, right? Okay, so now you can intersect each column at column, so each variable at column and each variable and the similar variable at row as well. For example, if I want to find out the correlation between total bill and tip, I can go to this cell. If I want to find out the correlation between total bill and total bill, I can go to this cell, right? Now, what is this correlation thing, right? How it helps us in data analytics or data visualization. So basically, correlation is it helps us in finding out the relationships between the variables. Wait a minute, variables are also having relationships? Yeah, they have sometimes. So basically the correlation value range, its range is from -1 to +1, right? Okay, so now what does this thing indicate? What does these values indicates in terms of relationship? So basically there are two types of relationship. One is directly proportional relationship and the other one is inversely proportional relationship, right? Okay, so if the value is +1 or close to +1, it means that there is a directly proportional relationship, which means if the value of each variable is increasing, then the value of relevant variable is also increasing. For example, age and salary. with the increase in age, salary also increases, and with the lesser age, salary is also less, right? So there is a relationship. So if each one variable is increasing, the other variable is also increasing. If one variable is decreasing, the other variable is also decreasing in a similar fashion or in a similar trend. Then the correlation is going to be +1 or close to +1, right? On the other hand, when it is going to be -1, when there is an inversely proportional relationship, which means that if a value for each variable is increasing and the value for the relevant variable is decreasing, and vice versa, right? They're going opposite to each other. So the correlation is going to be -1 or close to -1, right? There's a third scale as well. If the value is 0 or closer to 0, it means that there is absolutely no correlation between both of the variables, which means that there is completely randomness, right? Coincidentally, there is no negative value over here. So let me show the Titanic data frame dot correlation. Yeah, so here you can find a lot of negative values. For example, here we have this negative value, right? That is 0.58, almost 0.6 negative, right? Which means that a lone column and sibling spouse column have inversely proportional relationship. What do we mean by that? Since actually a lone column represents that if a passenger was alone or not, and sibling child column represents that how many siblings or spouses were there of each passenger on that Titanic ship. Now, if any passenger has any sibling or spouse on the ship, then he or she must not be alone. So that is an inversely proportional relationship, right? That is why value is in negative. Moreover, age and fare column, right? The value is almost 0, which means that there is completely randomness. There is absolutely no relationship between fare and age, right? So this is called correlation. Now we are back to our basic problem. These are the statistics. And what if we have hundreds of columns? Are we going to read each and every cell over here to find the relationship? The answer is no. The good thing is no. There's a thing called Seaborn that is going to rescue us. So we are going to say, hey Seaborn, you have something called heat map? Yeah, you have it. So go ahead and draw a heat map of this matrix, right? Run it. Here we go. So it has drawn a beautiful colorful heat map for us. And also let me do something like this, annotate equals to true, right? So this is a parameter for heat map that is by default false. You can make it true. So if I run it, so here we go. You can see the values, the annotations inside the cells as well. Well, this scale is showing that the lightest value is shows the extreme positive correlation, right? And the darkest value is showing the least positive correlation. So I can visually see that, hey, this is a black column, this is a black cell. So in tip and size variables, there's a very least positive correlation. Well, let's make this concept more concrete by visualizing this Titanic correlation, right? So here I'll say Titanic data frame correlation, and annotation is going to be true. So here we go, right? So now light value are showing the positive correlation and dark value are showing actually the negative correlation, right? Because we have the negative correlations in it. Moreover, the roughly purplish values are showing the 0 correlation, or it is showing that there is absolutely no relationship between these columns. Cool. Okay, now I can simply go ahead and I can find out the black cells that will help me out finding out where there is any negative correlation. I can simply go ahead and find out the light columns that will help me out in finding out the positive correlations, and I can simply go ahead and look at the purple column where there is absolutely no correlation, right? So this is how we can work with heat map and correlation. But what if I don't like these random colors? I want to have my own colors. So the good thing is in Seaborn we have color palettes where we can define our own colors, right? So here if I say reds, it will create a red palette for me. So I'll copy this, I'll come over here, I'll say C map, and here I'll paste this color palette, these color palettes, right? I run it. Here we go. So it is in red format now. Let's make it greens. So it is in green format now. Let's make it purples. Wow, what are the spellings of purples? Is it correct? Yeah, it is correct. So you can make it purple as well. So whatever color you want, you can customize it according to your need, according to your assignments, right? So this is how you can work with the color palettes and Seaborn. So this is how in this module we have talked about image processing, we have talked about Matplotlib, we have talked about Seaborn, and a lot of different types of charts as well. So I would highly recommend go to the documentation of Seaborn. You will find a lot of cool types of plotting and charts over there. And that's about it from this module. I'll see you in next module where we are going to talk about some cool aspects of data and data analytics.